Today's lesson is about the laws of motion, formulated by scientist and mathematician Sir Isaac Newton in the late 1600s to explain why things move as they do.
You mean like how my bicycle keeps rolling even when I'm not pedaling anymore?
Why, yes, that's an example of Newton's first law. It says, an object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. This is also known as the law of inertia. Inertia is the tendency of all objects to resist changes in their motion. The larger the mass, the more it resists change. A bicycle lying on the ground stays like that until an unbalanced force, like you lifting it, acts on it. And a rolling bicycle keeps on rolling, and it will only stop if an unbalanced force acts on it. In this case, the combined friction from the ground and air is the unbalanced force causing it to slow down.
Wow, so without friction, it'd keep on rolling forever.
That's right. Moving on to Newton's second law. The acceleration of an object depends on the mass of the object and the amount of force applied.
So?
Well, we know that to get an object moving, we have to apply an unbalanced force. Newton's second law says that a larger force will cause an object to accelerate faster than a small force will. If you're on a bike and a friend pushes you gently, you speed up slowly. But if she pushes really hard, you speed up really quickly, right? The larger the force, the faster the acceleration. Mass also plays a role. If we push a small child on a bike, and then we push an adult, and we use the same size force in both cases, they will accelerate at different rates. The child with less mass will accelerate quickly. The adult with more mass will accelerate slowly. Now, these bicycle riders also have momentum, which is the product of the mass of an object times the object's velocity. You can actually feel momentum. For example, it's difficult to stop a moving object that has a lot of mass, like a bowling ball, or that is moving at high velocity. Here, try catching a fast baseball pitch without a glove.
Ouch!
So, tell me how Newton's second law of motion affects momentum.
Well, since the second law says an unbalanced force causes acceleration, which is a change in velocity, then force also changes momentum.
Excellent.
The second law is all about a simple formulation. To get the force, just multiply mass and acceleration. If that's too much to say, there is an easy way. Try this abbreviation for this simple formulation.
F equals M-A, F equals M-A, F equals M-A. Now that's the abbreviation. F equals M-A, F equals M-A, F equals M-A.
Force equals mass times acceleration.
Newton's third law of motion states that forces act in equal and opposing pairs. For instance, you push down on the ground with your feet when you walk. You may not realize it, but the ground in return pushes up against your feet. When a fish swims in water, its fins push against the water, and that's called the action force. But without the reaction force of the water pushing back against the fins, the fish wouldn't get anywhere. Even a bicycle lying on the ground is an example of this law. The bike presses down due to gravity. If the ground did not push back up on the bike with a force equal to the bike's downward force, the bike would just fall through the ground.
But it doesn't, because the two forces are acting together.
And the world is made of energy, and the world is electricity, and the world is made of energy, and there's a lot inside of you, and there's a lot inside of me,
And that completes our lesson on Newton's 3 laws of motion. Now we know how forces act upon objects to influence motion, and we can move wisely through our world.